Okay, good day. Maulan? Di maulan? Okay. Um, for today, what we'll be doing is I'll be introducing to you guys your last topic for vibing, which has to do with the Runge-Kutta-Nyström method. Right? So the Runge-Kutta-Nyström method. The thing about this is, ito yung tinitease ko sa inyo na kailangan ng Excel. Right? The thing about the Runge-Kutta-Nyström method is that just with a lot of other just with a lot of other methods, this is what we call a numerical method. Right? So before we even begin with RKN, that's what we call it usually, RKN, right? Before we even begin, I have to tell you guys what a numerical method even is. If ever hindi niyo pa to alam, right? Let's say for example, we have a differential equation. We have a differential equation. There are generally two schools of thought, right? When you're trying to do a differential equation. The first one, of course, will be to try to solve it analytically. Kung alam mo naman kung paano gawin, right? At kung alam mo naman kung paano gawin, you can do it analytically. Let's say, for example, if you remember, let's say, for example, if this is a first order, pwede mong gawing variable separable, you can apply an integrating factor, those kinds of things. So, for example, like variable separable, exact equations, mga ganong klaseng bagay, right? Homogeneous coefficients, those kinds of things, right? And even, let's say, for example, the differential operator, right? Syempre, nandyan din yan. And then method of undetermined coefficients, it's all also here, right? So, MUC, all of it is in an analytical fashion. The thing with analytical methods is that makukuha mo mismo with your brain power kung ano yung solution, right? You get at the very end of it, right? A solution that works or that you can interpret, right? However, for a lot of the differential equations that we have currently, let's say for example, the heat equation. Let's say for example, the Navier-Stokes equation. What happens usually is that there are way too many variables or just we don't have the math language yet for us to fully comprehend, for us to fully analyze kung ano nga ba ang nangyayari. Right? So in this case, we employ instead numerical methods and let calculators or our computers handle our solutions for us. Right? So it's a numerical method. You might know this already way before with, let's say, for example, something called the bisection method. Naalala nyo yun? Like regula falsi, fixed point iteration. These are some of the things that you have learned from your numerical methods laboratory. Those are for finding roots to different equations. Iba rin naman ngayon kapag hahanap tayo ng mga solutions or ng mga ng data for differential equations. Right? Usually we employ things like Euler's method. You guys can look that up. Simpson's rule, trapezoidal rule, that's for finding the area under a curve. For now, we will have Euler's method, and then we will have RK4 muna before I go any other place, right? And then pupunta tayong RKN. The thing, the inherent parang disadvantage with a numerical solution is that you do not have a solution. Instead, what you have is just data, right? It's iterative. It results in not something like a y is equal to blah 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 blah. Hindi siya lalabas na ganyan. More so, it just gives you, right, the look of the equation. Right? And usually, ang ginagawa natin for us to validate, right, these methods right here is that we usually compare them to another problem where an analytical solution is available. And then, kapag may analytical solution, tinitingnan natin gaano kalapit yung ating mga predictions. Right? So that is usually what happens for differential equations. For a lot of the time, hindi talaga natin masosolve yan. So what we do is we let our computers solve, quote-unquote, solve it for us. Right? And before we even get into Runge-Kutta-Nyström or RKN, I suppose I should show you first RK4, the classic Runge-Kutta method. Right? The classic Runge-Kutta method, this is applicable for first order differential equations, right? So for first order differential equations lang itong ating RK4, right? So you might be wondering why RK4. It's because, well, you'll see later, for first order differential equations, right? So ang gawin natin is something like this. Just so you guys understand what's going to happen, right? We will try to solve something, right? We will try to solve a a first order differential equation, an analytical way, and also the numerical way. Just for us to understand kung gaano sila kalapit, kung ano ang itsura na magiging solution kapag RK4, and then we'll step up to RKN, see what happens, kumbaga. The thing about the Runge-Kutta method is that it's not currently useful to us. So honestly, if you guys would like, you can skip this part. Pero this, I believe, is the simpler version. Baka kasi mamaya you get lost in the sauce kapag pupunta kayong RKN. So this is, kumbaga, the baby method, right? So this is for first order differential equation. Let's say for example, I've created here dy over dt plus 3y is equal to 2t. So honestly, there are many different ways you can try to solve this. One of them, if makikita nyo, this looks like what do you call this? This looks like a linear differential equation. So if naalala nyo yun, employ an integrating factor. Right? Pwede yung integrating factor here. So, and use integrating factor. And then, what else? Pwede pa tayo. Ang gagawin na lang natin right now is we will try to use our differential operator. The thing about the differential operator in here is that this is just the same thing as y dot, right? Plus 3y is equal to 2t. The thing about this now is that, okay, pwede natin gawin is we can just use the differential operator, express this to be dy plus 3y equals 2t. So, makikita natin dito, currently this is non-homogeneous, right? So what we should do first is treat it as if it were homogeneous and then maglagay tayo ng guess later on using method of undetermined coefficients. So you might be wondering, bakit method of undetermined coefficients? This seems like overkill, and it is. It really is overkill currently. Pero, ito yung mga tinuturo kong, Ito yung mga tinuturo kong method, ito na lang gamitin natin. Right? What we'll do first is assume that this is indeed homogeneous. Dy plus 3y is equal to 0. You cancel out all of the y's. You will get d plus 3 is equal to 0. Meaning that your d is equal to negative 3. Meaning your current general solution will be ae raised to negative 3t. Okay? That is our current solution. And what we will do now is find our complementary solution based on this based on this, the right side will be 2t. So, ang gagawin... Oh my goodness. Ang gagawin kong solution na guess will be, complementary solution will be bt plus c. Right? This is a polynomial. So, ang gagawin natin is we account for all of the values, all of the, the values that are lower, or all of the powers pala that are lower than t, which is t raised to 1, right? So, if this is going to be our complementary solution, the derivative of that should be just letter b. And so, if ibabalik natin siya dito sa ating equation here, we will get, right? Y prime, or y dot plus 3y is equal to 2t, edi lalagay lang natin lahat. Y dot is just b, right? Plus 3 times y, which is 3b, 3 times bt plus c is equal to 2t. So we will have here 3bt plus, b plus 3c is equal to 2t. Na makikita natin, you will have here values that are stuck to t, and you will have here constants. Pero walang constant sa kabila, so we will just compare it with 0. So what we will have is, something like 3b, right? For the t's, we will have 3b is equal to 2. And then for the constants, you will have b plus 3c is equal to 0. So, ang lalabas is that b is equal to 2/3 here. B is equal to 2/3. And then your b, because your b is 2/3, let's make this happen here. 2/3 plus 3c is equal to 0. So, lipat sa kabila, you will have, 3c is equal to negative 2/3, meaning your letter C will be negative 2/9. So, finally, our final mega final answer, which is analytical, mind you, is confirmed by y is equal to AE raised to negative 3t plus, or minus pala, plus BT plus C, diba? So, plus 2/3 t, right? Plus C, or ito pala minus 2/9. So, currently, this is our answer, right? This is our answer. Ba't ayaw niya mag? Okay, hindi niya na-recognize. Alright, fine. Wait lang. Check ko lang. Okay, there you go. Parang paling. You can adjust. Okay. This is our analytical answer. Right? So, ito yung ibabangga natin later down the line when we have our numerical solution na. And a numerical solution, ito pa pala, another inherent disadvantage is that a numerical solution cannot be, what do you call this? Cannot be discovered without initial conditions. So, maglalagay ako ng initial condition dito. Let's say, for example, y at 0, at time is equal to 0. Ang sabihin natin ng y natin will be 3. If your y at your time is equal to 0 is equal to 3, edi gawin natin dito, 3 is equal to a e raised to, what is this? Negative 0, negative 3 times 0. And then ito ay 2/3 times 0 minus 2/9. So we will get here, this is cancelled, this is cancelled. So we will get 3 is equal to a minus 2/9. So ang a pala natin in here will be 7 plus 2, 29/9. Okay? So our final answer na particular solution na ito, right, will be 29/9 e raised to negative t and negative 3t plus 2/3 t minus 2/9. Ito ang ating answer pala. This is our answer. Now, yan yung ilalagay natin or yan yung ipang what do you call this? Yan yung ipang babangga natin when we do our numerical solution. And this one you don't need to remember naman because if anything, I will be giving this out in the finals, right? This is a bunch of steps that you need to do, right? First and foremost, you need to arrange, right? Arrange your function, right? Such that may iwan lang ay y dot. Y dot is equal to blah, 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 blah. Okay? So currently, this is our function, right? So we will have y dot plus 3y is equal to 2t. So our function ngayon will be y dot is equal to negative 3y plus 2t. This will be our function. And usually, kapag nag-research kayo something about this, you will always see this as y dot is equal to a function of, right, your time and your initial value or basta your value of y. Right? So yun ang makikita nyo usually. Okay? Something like this. And now, what happens afterwards, right? What will happen afterwards is that you will compute, right? Compute values of K1 to K4. Kaya apat. Kaya RK4. Right? First and foremost, we will have K1, which is going to be just this. Just your function here. Right? So kung ano man yan. If you guys remember, ang sabi natin, your y at time of 0 will be 3. So usually, ang pagkaano dito, ang pagsusulat dito is that your y at time of 0 will be your y at 0. Kumbaga. Right? Now, we will compute these values. Right? So sabihin natin, no, try natin. Unahin muna natin value of 0. Right? Para saan ba ito? Right? Let's just try this out. Negative 3 times y. Ano nga ba ang y0 natin? And negative 3 times y0 plus 2t0. Right? Ang t0 natin is literally 0 seconds. So 0 yan. Ito naman is going to be 3. So this will be negative 9. Right? Okay, negative 9. Now, K2, this is where things get a little bit complicated kasi ngayon makikita nyo na we will have t plus this value of h over 2, then your y0 plus hk1 over 2. Matataka kayo, ano yung h? The value of h here is what we call a step size. In here, right? What do you call this? In numerical methods, right? Ano bang nangyayari, right? We don't have an analytical solution. We don't have a y equals blah, 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 blah. We can only solve this using initial conditions. And finally, ang problema pa is that we need to have a particular step size, which means our computation is discrete. It does not produce a smooth shape. Kumbaga, kung ang totoong analytical solution natin is ganyan, ang magagawang solution ni numerical is like blocky. Right? It's based on these values, what we call step sizes. All of these guys have similar or same identical step sizes. Right? And ang nangyayari lang, identical wala dapat, is that it produces these values right here based on these step sizes. So, ang makikita nyo, or hopefully you will understand that the smaller the step size, the better the approximation. But also the trade-off is that the smaller the step size, the more iterations that you will need to compute the motion of something, the position of something, blah, blah, blah. Right? So there's always going to be a trade-off here. The thing about this now is that how do you alleviate that trade-off somewhat? Usually, hindi RK4 ang ginagamit. Right? Usually, if you want a very simple, very easy method, it's what we call Euler's method. You guys can try that out. It's very simple to compute. But the thing is, RK4 is arranged in this parang medyo complicated manner because what they want is higher accuracy for a single iteration. So in this case, kayo na bahala how you want the step size, how big you want the step size to be. For example, ang gawin natin is 0.1 seconds. Right? 0.1 seconds. Magtataka kayo, grabe, ang liit naman. Right? And now, ang gagawin natin is literally, we'll just do the same thing. Y plus H times K1 over 2, right? Plus 2 times T plus H over 2. So, ang magiging calculation is negative 3. Ang Y0 natin is 3 plus H is 0.1 times, ang K1 natin is negative 9 over 2. Right? And then plus 2 times T is 0 plus 0.1 over 2. So, you can grab your calculator. You can get this value. Let's get this value quickly. Nasaan calcu ko? Nandiyan ba calcu ko? Thank you. Okay. Negative 3 times 3 plus 0.1 times negative 9 over 2 plus 2 times 0 plus 0.1 divided by 2, you'll get negative 7.55. Negative 7.55. And now you can see how this gets very exhausting very easily. We go to K3. Thank you. We go to K3. Ay, sorry. Okay. We go to K3 and we realize na ito na naman, gagawin na naman natin, but instead of, right? But instead of using K1, you will now use the value of K2. So you can see how this is an iterative process talaga, right? Now, instead of K1 in here, you will use K2, right? So again, right? We will do this again and hopefully you guys get the pattern now. Ang mangyayari na ngayon is that we will just have, right? Ito, yan. We will just continue this value. Ang magiging lalabas dito is 3 plus 0.1 times negative, instead of negative 9, we go with negative 7.55 over 2. Let me put that in my calculator right now. And then your value of time will still be the same, right? 0.1 over 2. This will give us negative. Ito na. This is where it gets more parang complicated, right? Negative 7.7675. And then finally, we have our value of K4, which will be ito, F. And then we finally take a full step. Because if you guys think about it, these are half steps right here, right? These are now full steps, and then we will have Y0 plus, right, HK3. So full step na ito, right? We will now have negative 3, and then now this is a full step, 0.1 times negative 7.7675, and then plus 2 times 0 plus 0.1. We will have, okay, ulit. We will have now negative 6.46, negative 6.46975. And now we put all of this together so that we can find our next iteration. Compute the next iteration, right? So our next iteration will have to do with with our new value of y. Kasi naman yun yung pinapalitan natin, right? So our new value of y, our y1, are basically our new value of y is just going to be our old value plus h over 6 times k1 plus 2k2 plus 2k3 plus k4. So kumbaga, ganyan, gagawin natin, we will have our old value of 3 and then our step size of 0.1. And then we will put in all of our values of k. So 2 times what? Negative 7.55. Next, 2 times negative 7.7675. And then finally, our value of negative 6.46975. So let me compute this. So medyo matatagalan tayo dito. 0.1 over 6. Negative 9. To 7.55 to 7.7675 minus 6.46975. Our final answer will be, instead of 3, bumaba na siya ngayon to 2.2315875. Edi 2.2316 na. So that means, right? Thus, kapag nag-step ka pa, right? At new t, right? At new t, ibig sabihin, ang new time frame na natin will be 0.1 seconds. Ibig sabihin, at t1 is equal to 0.1 seconds, ang y1 natin is 2.2316. Itapat natin siya based on our analytical solution. Right? Based on our analytical solution, analytically, so lagay natin dito, analytically, right, at t equals 0.1 seconds, let's just put in here our y value. Lalagay natin dito. 29 over 9 e raised to negative 3 times 0.1 plus 2/3 times 0.1 minus 2 over 9 we get, hopefully medyo malapit, no? And it is very, very close. 2.2315. Right? Makikita nyo, the error is already apparent. Right? Meron na siyang error of about, ano nga bang error ito? Right? Ang error niya will be bigger than, right? It's bigger than our supposed value. It's bigger than 1 times 10 raised to negative 3. Ano ba? Hindi, negative 4 pala. So that is quite small. In all earnest naman, that is quite small. Pero the thing about this is that we only computed, all of this is for computing for 0.1 seconds. Right? What happens kapag nasa 1 second na, baka mamaya the error compounds and then we will see the kind of, yun nga, the kind of parang mistakes that this will bring. So this is why I'm going to ask you guys to, get your, calculators out, your laptops out, kasi honestly, ayoko naman pagawin kayo ng ganito on a calculator. Even if this is possible, this will take up so much of our time and I'd rather we don't do it. Right? So ang gagawin ko lang dito, you guys don't have to abide by all of this naman. Gagawin ko lang na medyo, what do you call this? Medyo monospaced ang ating font para mukhang okay. We will have y prime is equal to negative 3y plus 2t. Right? This is now our equation. And then, ang ating initial condition, right? Ang ating initial condition is what again? Y of 0. Right? Sorry, at time na lang, dito na lang natin lalagay time. And this is y. So, at time is 0, your y is 3. So, ang gagawin na natin in here is that we will put in all of our values for K1, K2, K3, and K4. Right? Ito ang gagawin natin na table. Right? And whatever it is, our new value for y, lalagay na lang natin dito. Y new. Okay? Excuse me. Now, what will happen is that we should put in here a step size somewhere. So, lalagay ko na lang dito. Ang ating step size ay, ang h natin will be 0.1. Right? I will refer to this. I will continue referring to this until later. Right? Pero for now, ang gawin na muna natin is that let's just set in all of our values for t. Right? Ang gagawin ko is that I will make it such that this is the old value plus our step size. Let me put that. Let me lock that. Right? Let me lock that. And then, we go on and on. Oops. Ano nangyari? Yeah. And we go, like this. Right? The thing about this is that what we can do, kailangan ko pala ng analytical insert. Yeah. Ito ang y analytical. Yan. Okay? We will have our analytical solution here that is going to be, 29 over 9 negative 3t. 29 over 9 plus 2/3 t minus 2 over 9. Right? So let me merge and center this. Let me wrap the text around para alam ko kung ano yung analytical solution. Right? And we will have the following. Right? Kung ano man yung new dito, yun ang ating gagawin. Right? How am I going to say this out loud? Kung ano yung new dito, yun yung ilalagay natin na value here. So this will be this. And then we can drag this down so that we can reference the new values from here. Okay? So, ang gagawin ko rin dito, instead of just making this 3, what I will do is that I will plug in whatever this is. Right? So, 29 exp negative 3 times kung ano man yung value natin ng time currently, plus 2 times our current value of time divided by 3 minus 2 over 9. Bakit to? Exponent. E raised to negative 3t. Oh, divide by 3. Oh, divide by 9 pala. Yan. And so now, our expectation should be something like this. Right? These are our values supposedly. And actually, pwede na natin yan i-track or pwede na natin yan i-graph for late. Actually, pa gawin natin hanggang 2. Yan. Hanggang 2 seconds just so we know what it looks like talaga. Right? Let me zoom out a little bit. Oops. Let me zoom out a little bit. And let's put this all in a graph or in a table pala rather. Let's make this Sir Jerry-esque. Yan. Gawin natin bright yellow. Okay? And now, we will try to compute for values of K1. So, ang value natin ng K1 will just be negative 3 times our value of Y, right? Plus 2 times our value of T. So, ganyan. Okay, negative 9. Tama naman tayo so far. Then we keep on going. Negative 3 times our value of Y plus, right? HK, right? HK1 over 2. So, H times K1. Saan K1? K1, ano to? This is F3 over 2. Plus 2 times this one plus H over 2. H over 2. And what I will do here, kasi, ba't walang value? F3 naman F3. Yeah. Yeah, negative 7.55. Is that correct so far? Yes. That's correct so far. What I will do pa here is that I will lock N2 because that value should not change as I drag it down. So hopefully you guys remember yung pagda-drag down sa mga cells sa Excel. What it will do is that it will transfer the what do you call this? The function, right? Down, right? Anyway, we continue. We go with negative 3 times Y plus H, right? Times K2 na ngayon, G3 divided by 2 plus 2 times this again, time plus H over 2. And before I go, what I will do is that I will put these in together. And then yun, negative 7.7675. Okay, good so far. And our K4 finally will be negative 3 times, right? Y plus H times K3, which is H3, right? And then plus 2, oh my goodness, plus 2 times time, nasaan ang time natin? Time plus full step na ngayon. Okay? Ayan. So, still good, looking good so far. Again, I will lock these values because itong si H dapat hindi na yan gumagalap. And then our Y new will just be this plus H over 6, right? Sabi natin H over 6 times K1 plus 2K2 plus 2K3 plus K4. So now that's our new value, 2.231588. So makikita nyo, parang same din lang. Right? And so what we can do now, before I do this pala, kailangan i-lock ko itong si N2. What we can now do is put this, we select this and then we drag this down. Okay, now these are the important values that we should consider. This Y right here is the numerical. So lalagyan natin Y numerical. And then this is Y analytical. As you can see, sa second iterations, parang same pa rin. Let's go with the 20th iterations. Buti, at it still is somewhat parang very similar to each other. Right? Let's just try. Ito na ang magiging test natin. Ang ultimate test natin is that how step size affects these things. Right? Ang step size natin ngayon is relatively small. It's at 0.1 seconds. What if we increase it to 0.5? If you remember at at the 20th iteration, maliit lang talaga ang kanyang error. But what if we increase this step size to 0.5? Oh, Oh, wow. Very close. Look at that. Very interesting. Okay, for some step sizes, it works well. What about one? Okay, there it is. Okay, that's where the thing fails, kumbaga. Uh that's where the RK4 fails. Syempre, ang lalaki ng step sizes nito. Well then, iba talaga ang mangyayari kapag ganyan. Right? What about let's say 0.25? So they really get it kapag 0.25. What about something like point, I don't know, 0.5? Oh, very exact apparently. Yeah, very exact. So yun nga, right? The general rule here is that step sizes lower, smaller step sizes result in more accurate parang computation, of course. Right? So if we put this back to point one, what we can do now is that we can graph, right? We can graph yung differences between the analytical and the numerical solution. Right? Let's try and insert a chart in here. Ito yung 2D line. Ito. So, lagyan natin siya ng data. Select data. We'll add series name. Ano ba series name? Oops. Remove. Ano ba to? Time? This one? Here. Axis labels. Sige, let's just add these things. Add lang. Sige lang. Add analytical here. Okay. So what we can do now, so we have a table. Ay, hindi, parang iba yung naselect kong data, I think. Horizontal. Oh, legend entries pala yun. Chart data range. Okay, you know what? Let's just put in everything in here. Yeah. There it is. So, tatanggalin natin ay itong mga K and then itong matitira na lang. Yeah. Okay. So apparently, wow, oh my gosh, lots of agreement between the two. Let's just have here, check natin yung legend. Let's have a legend right here. Oh my gosh, I can't even see the light orange at this point. Right? These are our number of iterations. So lagyan natin ng labels. Number, text options. Ito na lang pala dito. Axis titles. Alright, there you go. Data natin. Yan. There you go. And then, let's have here sa axis title natin, value of y. Value of y. And then, ito is iteration. Okay. Now, let's make this pop out talaga. Let's make this pop. Let's have a background for this. Color white. Ayan. Ay. Sorry, medyo umabot pa ako dito. Ayan. Okay, dapat white. And then, let's try and fix the colors here. Dapat ang color nito, color ng data na ito should be, I don't know, kasi hindi natin kita. Let's make it a bit more clear. 0.5. Ayun. Nakita na natin ang difference. Finally. Let's make this analytical is red. Sabihin natin, try natin red. Okay, so ba't hindi gumana? Can we not make it red? Ayun. Okay. And then for the numerical method, let's make it blue so it pops. Ooh. Ayan. Okay. So now we can see the differences here. Right? Now we can see the differences here. Let's try 0.3. Oh my gosh, hindi talaga siya nag-aano. 1. So, malayo talaga yan. Let's try 0.6. So, it's still good. 0.7. And then, it starts to taper off a little bit. 0.8. 0.9. Ayan. At some point, it just loses detail. Right? Yeah. It trails off, kumbaga. Yeah, ibang-ibang ating numerical solution. As you can see, right here, it goes up to what? Trillions or billions ba ata? Yeah. So anyway, right? It only works up to a certain extent. Sabihin na lang natin. Right? 0.7 is still a little bit good, I think. Yeah. But anyway, yun ang nagagawa natin for the Runge-Kutta method, the RK4 method. So of course, this is for a first order differential equation. And for a lot of differential equations naman, it's for a lot of the first order differential equations, okay naman. Right? For second orders, doon tayo nagkakaroon ng issue. Right? Because at some point, right, you might lack the skills, the certain parang knowledge to know, okay, this analytical method works for this case. So now, we will discuss the RKN method, right? The Runge-Kutta-Nyström method. So, Runge-Kutta, both of these guys are German. Yes, they're German. Pero si Nyström, because of the O in his name, I think he's what, Scandinavian? I'm not sure. So now we have the RKN method, which works for second order, right? For second order differential equations, right? Ngayon, of course, there's a bit more detail to this. So let's try it out with an example number 2. We will have ito, y double dot plus 3y dot plus 2y is equal to e raised to 3 negative 3t. Okay. And sabihin na lang natin y equals 0. It will be 0. And sabihin natin ang y dot at t equals 0 will be, let's say, 2. Yeah. Okay. Let's try this out analytically first, right? And this looks like we can use a differential operator. But then again, ang gagawin muna natin is let's think about this as if it were homogeneous, right? So, homogeneous muna, ang gagawin natin is i-zero natin yung right side. And then we apply our differential operator. This was derived twice, so d squared y. This was derived once, so 3dy. And this was not derived, so 2y. Then, cancel, cancel, cancel. We will arrive at d squared plus 3d plus 2 is equal to 0. Meaning, right, ang mga values natin ng d will be negative. Okay, factor ko na muna. Factor. We will factor this out to become d plus 2 and then d plus 1. Right? You guys can just confirm that later on. But what we will have here are values of negative 1 and negative 2. Meaning, ang ating general solution, right, will be AE raised to negative t plus BE raised to negative 2t. Okay? Looking good so far. So, ang gagawin na natin before we go on and find the particular solution is that we will develop a guess, right, for our complementary solution. In this case, our complementary solution, very easy naman, CE raised to negative 3t. Meaning, our y dot will be negative 3c e raised to negative t, and our y double dot will be just 9c e raised to negative 3t. You guys can chain rule that yourself. Now, what we will do is, solve lang natin kung anong value ng c. Right? I-insert natin siya. We will have 9c e raised to negative 3t, right? Plus 3 times negative 3c, right? E raised to negative 3t. And then plus 2 times y, so 2c e raised to negative 3t is equal to e raised to negative 3t. Everyone in here has an e raised to negative 3t. Edi cancel, 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 cancel. We will just be left with 9c minus 9c plus 2c is equal to 1. Edi ito ay cancel, cancel. And finally, our value of letter c in here is just going to be 1/2. That means that our general solution will be AE raised to negative t plus BE raised to negative 2t plus 1 half e raised to negative 3t. And now, if we apply our initial conditions, right? If we apply our initial conditions, we will have here 0 is equal to a e raised to negative 0 plus b e raised to negative 0 plus 1 half e raised to negative 0. The cancel, cancel, cancel. We will have first a plus b is equal to, lipat ko na lang sa kabila, we will have negative 1 half. Next, we derive. Right? Derive natin tong lalabas will be negative a e raised to negative t, negative 2b e raised to negative 2t, and then negative 3 halves e raised to negative 3t. And if we apply this, right, we will have 2 is equal to negative a e raised to negative 0 minus 2b e raised to negative 0 minus 3 halves e raised to negative 0 again. Right? Paulit-ulit na tayo. We will have, right? Ano ba ito? 2 is equal to negative a minus 2b minus 3 halves. So we can do, lipat natin sa kabila, we will have negative a minus 2b is equal to 7 over 2, or, ito na lang para mas mabilis, a plus 2b is equal to negative 7 over 2. What we can do, because this is now a system of equations, we can just ano nangyari? Yeah. We can just subtract, right? A minus A, cancel. B minus 2B, negative B. Negative 1 half minus negative 7 over 2 will be negative 3. Positive 3 pala, rather. Tama ba? Yes. So that means that your B is equal to negative 3. And that means that your A, if ililipat natin dito, right, will be equal to, 5 over 2. Yes. So, ayan. Ang ating particular solution now will be y is equal to 5 over 2 e raised to negative t minus 3e raised to negative 2t plus 1 half e raised to negative 3t. This is our analytical solution. Right? And again, ito yung ibabangga natin when we're now going to go with our RKN. And yung RKN, medyo mas involved ang kanyang... Oh my goodness, sorry. Medyo mas involved ang kanyang mga process. But again, we will still employ the same kind of iterative solution. First, we arrange. Right? And ang arrangement naman natin, if the last time iniwan natin or in-isolate natin si y dot, now we will have to isolate y double dot. So that means y double prime plus 3y prime plus 2y is equal to e raised to negative 3t. Ang magiging function na natin ngayon are y double prime, which is a function of time, your position, and your velocity will be equal to negative 3y dot minus 2y plus e raised to negative 3t. So you're going to see this is going to get messy real quick, right? Our computation here will be a bit more will be a bit more complex, right? We will have a first part which has to do with compute K1 and big K. Big K. Right? Yung K1, same lang, much the same way as last time, but now we will have everything. 1 half h times f. Right? F, yung t0, your y0, and your y dot 0. Right? Okay? So, ang gagawin ulit natin, let's just put in here yung mga initial conditions natin. Let's have y0 is equal to 0. Your y dot 0 will be equal to 2. And then your t0 is just, 0. Right? So we will go off of this. Ang gagawin ko na lang is that I will make this a bit more flashy para mas makita ko. 3y double dot 2y plus e raised to negative 3t. Okay. Now, what we will do is, lilipat lang natin lahat dito. Negative 3 times 2 minus 2 times 0 plus e raised to negative 3 times 0. So ito, cancel. This one, magiging 1. Right? So we will have negative 3 times 2, negative 6 plus 1 is negative 5. What we will do now, tumitingin ako, right? With big K is that we will now have 1 half h times y0 dot, right? yo dot plus 1 half k1. So makikita nyo yung k1 has, ano tayo ito? Has units of y prime. Right? Has units of y dot. Magkapareho sila ng units. Tapos itong k naman, magkapareho sila ng unit ng y. Right? So now we're going an extra layer in because second order differential equation usually deals with something about a change in a change. So we are dealing with two different kinds of change here, a second order kind of change. So kailangan may ganito rin. Ay, sorry, hindi lang pala to negative 5, no? Let's have as well our step size of 0.1. Right? So this is not just, ano tayo ito? This is not the whole of k1. This is just the whole of the function here. Right? So magiging function natin dito will be multiplied by, right? Will be multiplied by 1 half times 0.1. So, okay, negative 6 plus 1, negative 5 times 1 half times 0.1, we will have negative 0.25. Okay, now we continue. Oh, nasan na ang aking, ayun. We will have 1 half times 0.1 times yung y dot 0 natin, which is 2, plus 1 half k1. So, negative 0.25. Right? Okay. Now, we continue. We 1 half times 0.1 times 2 plus 1 half times 0.25. Negative 0.25. We will have, ano lang, 3 over 32 na lang. Sabi ng calcu. Okay. Next, we will compute K2, K3, and what we call L. Right? K2, K3, and L. So, makikita nyo, mahaba-haba itong ating calculation. Right? K2 will be 1 half HF, and then we will add a step, half step pala rather, half step, and then for the Y, excuse me, for the Y, we will add our value of K. And then for a Y hat, right? Y hat tuloy. And ang dami ko nang sinasabi, Y hat, Y dot, Y prime. For our Y dot, we will add our value of K1. Okay? So, this will be 1 half times 0.1 times our function. Our function nga pala is negative 3. Gawin ko na lang square brackets. Negative 3 times our Y prime or our Y dot, malalagyan natin ng K1. Ang value ng K1 which is 0.25. So, minus 0.25. Minus 2, tama ba? Minus 2 times Y. Lahat ng Y ay papalitan natin ng Y plus K. K natin is 3 over 32 plus e raised to, right, negative 3 times 0 plus a half step. Right? A half step. 0.1 over 2. And we'll now put this all together. Ang lalabas na value ng K2 will be negative 3, 2 minus 0.25 minus 2 times 3 over 32 plus e raised to negative 3 times 0.1 over 2. We will have a value of negative 0.2288. And now this is where things get very messy. Right? Uulit tayo for K3. And the thing for K3 now, honestly, pwede ko ba itong Yun, pwede na ako copy-paste. Oh my goodness. Oh, I feel so powerful. Anyway, tanggalin natin to. Our K3 value now will just be, kumbaga, a replica of everything so far, except this one will be replaced with K2. So honestly, ito rin pala, pwede nating magaya. Copy-paste. We'll now have this. Okay. Ang magbabago lang is ang value natin ng K1 magiging K2. So, itong 0.25, gagawin nating 0.2288. Okay? We will have that. And ang lalabas daw is 0.3007. Negative 0.3007. Okay, before we continue with K4, kailangan natin ng L. And now L is going to be H times Y0 dot plus K3. So, kumbaga parang so far, ito ang ating calculated change. Right? So, this will be 0.1 times our Y0 dot is 2 plus ang value natin ng K3 is magma-minus pala tayo 0.3007. We will now have (0.16993). 0.16993. And then, finally, we compute CK4. Kasi after this, we will now add up all of our different displacements, all of our different changes for the next iteration. So, ang K4 na natin ngayon will be 1/2 HF. Now, instead of a half step, we will go with a full step. And then instead of Y0 plus K, we go with Y0 plus L. And then instead of Y0 dot plus K2 or K3, we go with 2K3. So parang doble, right? So again, like I don't recognize, or rather, I don't expect you guys to be able to like just memorize this offhand, right? So ang gagawin nga talaga natin is just we will make it fair. Bibigyan ko kayo ng mga notes, right? At least for RK. Okay? So this will now be plus 2 times 2 plus 2 times negative 0. Wait lang. Tama. 0.3007 and now minus 2 times 0 plus, right? Yung L natin 0.16993, right? Plus E raised to negative 3 times 0 plus 0.1. Yan ang ating value of K4. Let me put this in my calculator. Negative 3 times 2 times 2 plus 0.3007 minus 2 times 0 plus 0.16993 plus E raised to negative 3 times 0.1. We will have a value of negative 0.1897. And now, we compute for our next iteration. Compute next iteration. Right? Our next iteration will have two components. Right? We have our new value of y and our new value of y dot. Right? So, magiging y value natin ay y dot 1 is equal to our original, y1 lang pala is equal to y0 plus h times, ito na ang ating mga contribution. Y0 plus, y0 dot plus 1/3. Gawin ko itong square bracket. K1 plus K2 plus K3. And then, ang ating bagong velocity will be our old velocity plus 1/3. And then, ito yung makikita natin kind of the same as before. Right? K1 plus 2k2 plus 2k3 plus k4. Right? And then finally, of course, our new time will be our old time plus our step size. Yeah. Right? So let's just compute all of this. Right? So our y0 is just 0 plus h times our y0 dot is 2. It's 1/3. Ano ba yan? Mag-ano ako? Square brackets. 1/3 k1 was, ano nga ba yan? 0.25. Our K2 was 0.2288. And our K3 was 0.3007. So it's that 0.1 times 2 plus 1/3, negative 0.25, negative 0.2288, negative 3007. We will have 0.1740. Yeah. And then our new value of y1 or y1 dot. Itong bagong ating velocity, we will have 2 plus 1/3. Ano ba? 1/3 to pareho. Okay. Tama naman. 0.25. Let's make this again, square brackets. Plus 2 times 0.2288 plus 2 times negative 0.3007 and then minus itong ating K4, 0.1897. So let us put that all together. 0.25, 2 times 0.2288, 2 times 0.3007, 0.1897 afterwards. We will have 1.5. 1.5004. Yan ang ating bagong value. That means, right, 0 plus 0.1. That means, ang sinasabi numerical at t equals 0.1 seconds, ang mangyayari sa ating y is 0.174. Mangyayari sa ating y prime will be 1.5004. Right? Okay. Let's try it out. Let's bump it against our value of y na analytical dito. And let's also just derive it for good measure. Right? 5/2, 1 e raised to negative t plus 6 e raised to negative 2t minus 3/2 e raised to negative 3t. Okay? So, okay. Check na lang natin. Let's put in our values of x equals 0.1 here, 2.5 e raised to negative 0.1, negative 3 e raised to negative 2 times 0.1, and then plus 1/2 e raised to negative 3 times 0.1. We will get, parang okay, eto na nga, parang iba na nga. Analytically, at t equals 0.1 seconds, our y value will be 0.1763. So medyo malayo-layo na agad. And then our y dot will be, let's see, hopefully mas malapit this time around. Plus 6 negative 1.5. We will have, okay, medyo malapit-lapit na rin, 1.5391. Medyo malayo, minsan medyo malapit. Maybe it's because of our step size. Maybe that's too big in the case of RKN, but we will see, right? We will have our RKN this time around. So, try ulit natin to, but now a bit more complicated, right? RKN method. Let me just fix this. Gawin ulit natin na monospaced. Okay? And then, this is our y double dot is equal to, ano yun ulit? Negative 3y minus 2y plus e raised to negative 3t. Yan ang ating equation. And our analytical solution was, ano yun ulit? Y is equal to 5 halves. So, 2.5 e raised to negative t plus, or minus pala, minus 3 e raised to negative 2t. And then plus 1 half e raised to negative 3t. This is everything we know so far. Wrap text. Yeah. Now, what we will do, same as before, right? We will have time in y numerical. Time. Gawin natin bold lahat dito. Let's put in here yung numerical and analytical together, right? We have K1 and then big K, K2, K3, L, and then K4. Ay, hindi. Kailangan pa natin ng kailangan pa natin ng y dot. Right? Kailangan pa natin ng y dot. So, we have K1, K, K2, K3, L, K4. And honestly, you guys don't need to, kumbaga, you don't need to follow whatever it is that I'm doing. If ever you see or if ever you find out a better way to do this, then that's very, that's very good to hear. Kumbaga. Right? So now, we'll have is 0. Ang numerical natin, ang sabi natin in here would be, ito 0, and then this one was 2. So, lalagay ko rin pala dito ang ating value ng y dot. Right? Y dot is negative 2.5. And then plus 6 times negative 2t. And then minus 1.5 exp negative 3t. That's it. And now, okay. Let's just put all of this together. Right? Actually, ito na lang muna. This old one plus this one. So, S2. Then, we stretch it out to however many. Sige, gawin natin 2 pa rin. Let's make it 2.5. Ayan. Okay. Let's try it out. Right? Let's try it out. Ang gagawin ko na agad, medyo, I'm getting ahead of myself. Your new value here should be the old value here. Right? And we go on and on. The new value here should be the old value here. So again, on and on. And then yung analytical natin should just follow ito. 2.5 times negative time minus 3 times negative 2 times time plus 0.5 times negative 3 times time. Ba to? D3. And then we just put it together like this. Ayan, yun yung mga values natin. We continue with this, negative 2.5 e negative time plus, oh my goodness, plus 6 times exp negative 2 times time. Ano yun? Minus 1.5 ata yun. Minus 1.5 exp. Well, makikita natin if mali ako. 7. Okay, negative pala. Sorry. Yes, okay. Okay, good. Okay. Everything so far is looking good, right? What we can do now is put in our values here. Make this a table. Okay. And then this is our H. Lagyan natin. Okay, now, our K1, ito nga, kahit ako hindi ko na naaalala, 1/2 times H times whatever it is that our function is going to be, currently negative 3 times our y analytical, y prime analytical, that is going to be H3 plus, ano ba yun? Or minus pala, minus 2 times Ano ba ito? Minus 2 times our y analytical, right? Plus, oh my goodness, plus exp negative 3 times our time. Our time is what? D3? Okay. Yan. Negative 0.25. Is that right? Okay. Looking good so far. Our K naman is 1 half H. Sige. Titingin na lang ako sa other screen ko. 1 half H times yn dot. So, yn dot plus 1 half K1. So, that would be I3. Yun ba ang 3 over 32? Check nga natin. Okay, good so far. What I realize I haven't done yet is i-lock ang ating mga values for step size. There you go. Okay na yan. And then, i-lock din ito. Values for step size. Next, K2 and K3. Right? Okay, ang gawin natin is 1 half step size. Right? Times negative 3 times, okay, ang y dot value lalagyan natin ng K1. So that would be I3. Okay. Minus 2 times, ito lang naman yung mahirap sa simula. Ang y value lalagyan natin ng K. So that will be J3. And then, plus exponent negative 3 times our time, lalagyan natin ng half step. 0.5 times S2. Let's close this. Okay. Okay, 0.2288, still good. Let's keep this going. Let's copy paste this. Pero, ang iibahin lang natin will be K1, anong value natin ng K1? This I3, gagawin natin K2, which is K3. Okay? Negative, oh nako. Baka kaya mali ako ng lagay. Kasi ang nangyari dito sa atin, negative 0.3007. Same lang naman ako ng nilagay everywhere. So you know what? Let me try again with my calcu. Negative 3 times 0.1 over 2. Oo nga no, negative 2320. Nako. Magkaroon na tayo ng problem. Well, makikita na natin, feeling ko naman this will give us a more accurate representation of this. Right? L naman ngayon will be K3, which instead of this will become 2320, and this will be edited to become 0.2320. So will become 0.1768. 0.1768. So ito, gagawin natin 0.1768. This one we will do 0.2320. You guys get the gist. So kumbaga, iba na ito, iba na rin ito, and then this one. Right? So hopefully our values here will be much closer. Let's just let the Excel take care of it all. Okay? Our L now will be H times Y dot plus K3. So our K3 is L3 actually. So 0.1767. Okay, 176799, so 1768. Okay, good so far. Our K4 is going to be, all right, isa pa, 1/2 H, and then negative 3 times yung y dot malalagyan ng y dot, right? Y dot plus 2 times K3, which is L3. Minus 2 times yung lahat ng y malalagyan ng L. Lahat ng y malalagyan ng L, which is M3. And then plus, ba yan? Plus exponent negative 3 times yung ating time malalagyan ng isang full na step. Isang full na step. So S2, and here lalagyan natin ng dollar sign, and hopefully we close, and this will give us negative 0.21103. Okay. Now our y new will be dictated by our y old. So y old natin, this one, plus h. So ito h, isa pang h. Oops. H times y dot plus, ano ba ito? 1/3. Okay, 1/3 times K1 plus K2 plus K3. Okay, that's 0.176305. Okay, okay, it's good. It's good. It's getting good. And then our y dot na new will be y dot na old plus, ano ba to? 1/3 times K1 plus 2K2 plus 2K3 plus K4. Okay, that is our new value of y dot, 0.539. Okay, we're doing good. And finally, we can stretch this all the way down. And hopefully, makikita natin that the values here are going to suggest somewhat of the same thing. Okay? So we will have a graph here. Insert tayo ng linya. We'll see right here. That's looking good. I'm really happy with what's currently happening here. Isog pa natin ng konti. Let's have axis titles. Tanggalin natin chart title. Lagay tayo legend. And actually, meron pa ako itong data na ito. Hindi naman natin need. Yeah, hindi naman natin siya need. Actually, dapat itong edit na ito, dapat ito yun. Dapat tinanggal ko na ito. Yeah. Yes, something like this. Okay. Hindi pa natin masyado nakikita ang ating mga values. So let's compress these guys. Yan, siguro pwede na ito. Let's have them edited a little bit. Let's have this as a solid fill. Ayan, okay na. And then, ito ay value na lang. Value of y and y dot. Right? And then this is our time. Pwede na pala yun. Time. In seconds. Right? Ito siguro parang untian na lang natin. Labels. Tick marks. Sige, pwede na to. Right? We can have this. But what's happening currently is that you can see, hindi natin makita ang ating numerical solutions because they agree so well with our analytical solutions. Right? If I stretch this out like this, lagyan natin, ibaba natin. Wala talaga. Right? Let's try increasing our step size, 0.25. Okay, nakikita ko na ng konti yung blue dito, but still, okay, I can see a bit of orange there. What about 0.5? It's now it's now getting a bit more sparse, I suppose. And ngayon, yan, lumalabas na ang it's getting Okay, yan. So lumalayo at lumalayo na ang ating mga values. So if anything, we need to keep it just a little bit more controlled, right? 0.3 is good, 0.25 is good. Yeah. Yan. Yan ang ating mga nagagawa with the help of with the help of numerical methods. The thing about this is that yun nga, there's always the trade-off wherein if you want a more accurate, right? A more accurate graph, well, compute for smaller and smaller step sizes. But of course, that takes up computational power. Let's have this time seconds. Ang gagawin na lang natin dito is that let's select our data. Let's edit it to become this. Y numerical, Y. Okay. Yan. So, hopefully this changes as well. Yep, okay, it does change. Yun. So, makikita natin the involvement lang talaga of these different values, right? And now we're graphing two different lines in here because, well, we have the displacement, right? The position, and then the velocity because we are looking for two different kinds of change, right? This is second order differential equation. So, makikita nyo, even still, these guys and these guys are going to be terribly, terribly similar, right? Even at the last one, even at the 26th iteration, same pa rin sila, right? Very cool. Yun lang naman. And I don't know, I kind of don't want to give you guys yung, this is possible for 2 degrees of freedom, for multiple degrees of freedom, but I feel like that's gonna be way too overkill. Although I kind of want to. Pwede naman. Well, let's see. Let's see how it'll go. But ayun na muna. Thank you very much for your participation. Right? If it is correct. Okay. Thank you guys very much for your participation and your attention for this. I know this is a terribly, terribly boring lesson kasi nga ang dami nating parang tedious calculation in here, and at some point, right, nag-iba or namali ako ng calculation. So this is very prone to error if the human is doing it, right? Kasi we can't detect these patterns so clearly, especially just go, this is just one iteration and already took us like what, 5 minutes to just write down, right? So that's gonna be terrible unless we get the help of calculators, right? So yun lang naman, right? I will be asking you guys to like model, right? Either through analytical methods or numerical methods sometime for your finals. So this is how we'll do it, right? Thank you very much, and good luck sa pag-aaral nito, right? Ito naman, buti nga at my computers, okay? Thank you guys very much.